Hi everyone. In this session, I am going to discuss about the problems on nodal analysis. Already we discussed about how to find electrical parameter by using loop analysis. Loop analysis means by applying Kirchhoff voltage law. Then by solving the simultaneous equation, yes, we can find out the different electrical parameter. Similarly, how we can apply Kirchhoff current law for any circuit to find out branch current or branch voltage. Here we are applying Kirchhoff current law for a node. First, let me explain about what is node. See, node is a common terminal for more than two branches. We can call this as a node. There is a difference between junction and node. Junction is a common terminal for two branches. Node is a common terminal for more than two branches. Generally, we are applying Kirchhoff current law for node. We are not required to apply Kirchhoff current law for junction because in a junction, the path is a single path. Even though that is a common terminal for two branches, there is only one path for a flow of current. So, we no need to find out different branch current because the current flowing through both the elements same. That is why we always apply Kirchhoff current law for a node. Is that clear? Next, say how many nodes are in this circuit. Before applying Kirchhoff current law, the first point is finding how many nodes in the given circuit. Say in this circuit there are two nodes. Let me call this common terminal point is node number 1, that is V1, and this is the second node and let me call it as V2. See, this is not a node because it is a common terminal for only two branches, this one and the 4 ohm resistor and this 10 volt voltage source. And moreover, all are shorted, we can call this as ground point. Clear? Now, for a given circuit, only two nodes are there. So, anyhow, we already explained what is that Kirchhoff current law states that. Kirchhoff current law states that the algebraic sum of current, the algebraic sum of branch currents entering into node is equal to algebraic sum of the branch currents leaving from the node. In another way, the algebraic sum of current at node point is equal to 0. Is that clear? The algebraic sum of branch currents at node point is equal to 0. First, I would like to explain how to apply Kirchhoff current law for node number 1. So, first apply KCL for node number 1. Okay. First, say this is the node number 1. This is a common terminal for three branches. The first branch, these two are connected in series. This is the first branch and 4 ohm resistor is the second branch and 5 ohm resistor is the third branch. So, there are three branches connected to this node. First, next, so according to statement, the algebraic sum of the current at node point is equal to 0, right? When you are applying KCL for any node, just assume that that is a higher potential node. Higher potential node in the sense, the current always flows from higher potential to lower potential. First, let me find what is the current in this branch. So, by Ohm's law, I is equal to V by R. V is nothing but potential difference. See, this branch terminal that is between, one is the V1, after the 2 ohm resistor is connected, then this 10 volt voltage source is connected in series, finally that path is connected to ground point. So, the entire branch is connected in between V1 and ground point, I mean the potential at ground point is equal to 0. Therefore, the current always flows from V1 to ground. With that, there is a additional supply, I mean additional voltage source is connected in that branch. Whether this voltage source driving the current opposite to this branch current. I mean, what we are assuming, current is flowing from V1 to 0, whether it is supporting or opposing, that is the point. Because you know, electrons always high at positive terminal, higher potential, and electrons always flows from higher potential to lower potential, but conventionally current always drives opposite to electrons direction. That's why current direction upwards. But when we are applying KCL for any node, we are considering that node is higher potential. That's why all the branch currents are leaving from that node. Is that clear? That's why current is flowing from V1, but this 10 volt voltage source supplying the current upward direction, I mean opposite to our assumed direction. That's why the potential difference between these two terminals is V1 minus 10. Is it clear? So V1 minus 10. After that, from 10 volt voltage source, it is connected to ground. What is the potential at ground? 0. Instead of writing minus 0, I will leave as it is. So V1 minus 10. This is the voltage. But what is the formula to find out the current? I is equal to V by R. V is nothing but potential difference divided by R is what is the resistance in this branch. What is the resistance in the first branch? 2 ohm resistor. That is 2. Is it clear? I think. Next, this is the first branch, current. The second branch is connected between V1 and ground. So, the potential difference across this resistor is V1 minus 0 divided by resistance 4 ohm resistor. That's why plus the potential difference across 4 ohm resistor is V1 minus 0, because V1 one end is connected to V1, another end is connected to ground point 0 divided by 4 ohm resistor. Is that clear? Finally, the third branch, this 5 ohm resistor is connected between these two nodes, V1 and V2. Right now we don't know whether V1 is higher potential or V2 is higher potential. Later, after solving these two equations, we will come to the conclusion what is the value of V1 and V2 and which one is the higher potential. Right now we are applying KCL for node 1. Let us assume node 1 is higher potential. That's why current is flowing from V1 to V2. Therefore, the potential difference across 5 ohm resistor is V1 minus V2. So, plus V1 minus V2 divided by 5. That is equal to 0, because there is no other branch connected to the node point. Is that clear? So, later we can simplify this equation. How we can simplify this equation? First, just split this first part, V1 by 2 minus 10 by 2, 5 plus V1 by 4 plus V1 by 5 minus V2 divided by 5, that is equal to 0. Just I am explaining how in simple way we can simplify the applied equation. Next, just group the V1 factors. First, let me take V1 as a common factor. 1 divided by 2. V1 as a common factor. The remaining part is 1 divided by 2. Similarly, plus 1 divided by 4 plus 1 divided by 5. Okay. Next, minus V2 divided by 5. Then what is the remaining term? That is 5. So, minus comes to our right side plus 5. Okay. Later you can use your calculator and you can simplify this equation. What is 1 by 2 plus 1 by 4, 1 by 5? What is that value? 0.95 V1 minus 0.2. What is 1 by 5? 0.2 V2, that is equal to 5. And call this as equation number 1. I think now it is clear how to apply KCL for node 1. Now let us apply KCL for node 2. Yes, KCL for node 2. Yes, again, how many branches are connected to node 2? There are 3 branches connected to node 2. One is 5 ohm resistor, other one is the 8 ohm resistor, other one is 10 ohm resistor. Again, that is connected through 20 volt voltage source to the ground point. Next, let me start with the first branch only, 5 ohm resistor. Say again, when you are applying KCL for any node, just consider that node is higher potential, therefore all the branch currents are leaving from the node. So let me mark all the branch currents leaving from the node. So right now we are applying KCL for node 2, current is flowing from node 2 to node 1. So in the previous case, we applied KCL for node 1. That time we considered node 1 is higher potential, that's why current flowing from V1 to V2. Now it is from V2 to V1. Later, after finding the value of V1 and V2, we will come to the conclusion whether the current is flowing from V1 to V2 or V2 to V1. Is that clear? Now V2 minus V1 divided by 5. V2 minus V1 divided by 5 plus. So what is the current in 8 ohm resistor branch? Current in 8 ohm resistor is V2 minus 0 divided by 8, 0. Why it is 0? Because one end is connected to V2, another end of 8 ohm resistor is connected to ground. I mean that potential is 0. So anyhow, the potential difference between these two terminals is V2 minus 0, that is nothing but V2 divided by, what is the current in this branch? By Ohm's law, I is equal to V divided by R. V is nothing but V2, R is equal to 8 ohm resistor. That's why V2, let me write 0 also, divided by 8. Okay, now last branch, again the current is flowing from V2. Another, I mean final end is connected to ground through this 20 volt voltage source. But again this 20 volt voltage source polarity indicates current flowing upwards. This is opposing this branch current. That's why V2 minus 20 minus 0 divided by 10 ohm resistor. So plus V2 minus 20 divided by resistance value 10 ohm, that is equal to 0. This is the KCL equation for node number 2. Now again let me simplify this equation. First split the first factor, V2 by 5 minus V1 by 5 plus V2 by 8 plus V2 by 10 minus 20 by 10, 2, that is equal to 0. Okay. Next, group the first factor, what is that? Minus V1 by 5. Next, V2 as a common factor, V2 common factor 1 by 5 plus 1 by 8 plus 1 by 10. The remaining term 2, that comes to RHS plus 2. Now just simplify, 1 by 5 is equal to minus 0.2 V1. Next plus, just simplify this part by using the calculator. What is that value? 0.425 V2, that is equal to 2. And call this equation as equation number 2. So for a given circuit, there are two nodes. We applied KCL for both the nodes and we got two equations with two variables. It is not a AC circuit, it is a DC circuit, so that you can use your calculator directly. We can find out what is V1 and V2 by solving equation 1 and 2. After writing this equation 1 and equation 2 in matrix form, first write the simplified KCL equation in the matrix form. Then by solving these two equations by using the calculator, yes, we can able to find out V1 and V2. Now we can clearly we can say which one is higher potential and which one is the lower potential. V2 is greater than V1, so that current flows from V2 to V1. The final conclusion is V2 is higher potential compared to V1, that is why current is flowing from V2 to V1. Now the point is, yes, of course, we applied KCL equations and we simplified the KCL equation and write it in the matrix form, and we solved both the equation. Finally, we got what is V1 and V2. Now, by knowing these two values, I mean V1 and V2, what are the factors we can find out? What are the electrical parameters we can find out? See, first thing, if you want to find out what is the current through this 4 ohm resistor, what is the current through this 4 ohm resistor, just tell me what is the formula to find out the current by Ohm's law. I is equal to V by R. What is V? Potential difference. So, let me indicate like this. Current through 4 ohm resistor is equal to V1 minus 0, because that is the voltage across 4 ohm resistor. So, let me call it as V1 divided by what is the resistance value? 4. So, we already know what is the value of V1, that is 6.9 divided by 4. Similarly, if you want to calculate what is the current through this branch, V2 by 8. If you want to find out what is the current through 5 ohm resistor, V2 minus V1 by 5. So, if the question is what is the voltage across 5 ohm resistor, let me write what is voltage across 5 ohm resistor. Now, you know what is the value of V1 and V2, whether it is V1 minus V2 or V2 minus V1. If you consider V1 minus V2, you will get negative value. Voltage never be negative. If the voltage value is negative, the conclusion is whatever the polarity we are considering, that is wrong. The right polarity is opposite to our assumed polarity. Is that clear? That is why always higher potential minus lower potential. That is why V2 minus V1. Thank you. Let us move on to the next problem. Once again, based on Kirchhoff current law. Again, the question is, by using nodal analysis, find out V1 and V2. V1 and V2 are nothing but node voltages. In previous problem, we solved, in previous one is the simple problem without any current source and even without any intermediate voltage source. See, in this problem, first let me mark, this is V1. Anyhow, that is in the question itself, find V1 and V2, that is given, V1 and V2. But in the first node, there are 3 branches connected. One is the 12 ampere current source, another one is 10 ohm resistor, next 5 ohm resistor. See, when you are applying KCL for any node, already I mentioned, just consider this is a higher potential node. That is why current, all the branch currents leaving from the node. But why we are applying KCL? In order to find out node voltages. But what are the parameters we are finding? Algebraic sum of branch currents, right? Already what is the amount of current flowing in this branch? Directly we given. The amount of current flowing in this branch directly given. No need to apply the Ohm's law. I mean, by considering V divided by R formula, no need to calculate current because already current is given. But the polarity of that current, the direction of current is very important. We are applying KCL for node 1, current is leaving from the node. But given current source direction opposite to our assumed direction. That is why this is minus 12. First KCL for node 1. Okay. So, when you are applying KCL for node 1, what is the current in the first branch? 12 ampere. No need to apply V divided by R formula. Directly given, current source is given, that is 12 ampere. But we are applying KCL for node 1. The current is flowing from the node 1 to ground, but the given current source flowing upwards. That is why this is minus 12. If the direction of the current downwards, yes, it is 12 ampere only. Now, what is the current in the second branch? You know that V1 divided by 10, because this 10 ohm resistor is connected between V1 and ground. So, the current always flows from higher potential to lower potential. V1 minus 0 divided by 10. Similarly, what is the current in the next branch? In this branch, yes, V1, yes, 20 volt voltage source is there. According to this polarity, it drives the current in reverse direction. That's why V1 minus 20, after that is connected to V2. We need to consider all these voltage values. That's why V1 minus 20, again minus V2 divided by, what is the resistance in this branch? 5 ohm resistor. That is equal to 0. Now just simplify this equation. Yes, V1 by 10 plus V1 by 5 minus 20 by 5, 4 minus V2 by 5, that is equal to minus 12, come to this side, plus 12. So next V1 as a common factor, 1 by 10 plus 1 by 5. Next minus V2 by 5, that is equal to 12 plus 4, 16. Okay, after simplifying this above equation, so this is the value 0.3 V1 in place of 1 by 10 plus 1 by 5 is 0.3 V1 plus 1 by 5, 0.2 V2 sign minus, so 12 plus 4, 16. So similarly, KCL for node 2. KCL for node 2. Just consider node number 2. Yes, this is the node 2. How many branches connected to node 2? This 5 ohm resistor, one branch, and again 5 ohm resistor with different value of voltage sources. First, let me start with this branch V2. Now we are applying KCL for V2, all the branch currents leaving from the node. At the same time, this intermediate 20 volt voltage source also supplying the current in same direction. That's why V2 plus 20. Okay, so the potential difference between these two terminals is V2 minus V1. At the same time, one more 20 volt voltage source is connected in series. That is also supplying the current in reverse direction only. That's why that is going to add with V2. So V2 plus 20 minus V1 divided by resistance value 5. Is that clear? Next, another branch, second branch, V2, see this 15 volt voltage source supplying the current upwards. But from current is flowing from V2 to ground, that's why V2 minus 15 divided by, what is the resistance value? 5. Okay, now consider the last branch. See, in the last branch 10 volt voltage source supplying the current in downwards. I mean it is supporting V2. That's why plus V2 plus 10 minus 0. Why it is minus 0? Because end terminal is connected to ground point. That's why V2 plus 10. So just ignore that 0 value because finally the end is connected to ground. V2 plus 10 divided by 5. V2 plus 10 divided by 5, that is equal to 0. Okay, first let me simplify this equation. First minus V1 by 5 plus V2 by 5 plus 4 plus V2 divided by 5 minus 3, because minus 15 by 5, 3 plus V2 by 5 plus 10 by 5, 2, that is equal to 0. First written minus V1 by 5, V2 by 5, 20 by 5, 4, V2 by 5, 15 by 5, 3, 20 by 5, 10 by 5, 2. Now just group accordingly. Minus V1 by 5 plus V2 common factor, first 1 by 5 plus 1 by 5, next plus 1 by 5. Then remaining values, so plus 4 minus 3. So 4 minus 3, 1, 1 plus 2, 3, that is equal to minus 3. Is that clear? Yes, after simplified this second equation, minus 1 by 5 is minus 0.2 V1. After simplifying this factor, 0.6 V2 minus 3, and call this as equation number 2. Right now, both the equations are available. Both the equations are available. Let me call this as equation number 1 and equation number 2. And write these two equations in a matrix form, because two equations with two variables V1 and V2, because this is a DC circuit, easily we can solve these two equations, simultaneous equation, by using your calculator. And what is the value of V1? 64.3 volts and V2 16.43. V1 is higher potential compared to V2. Finally, what is the conclusion? Current is flows from higher potential to lower potential. I mean V1 to V2. Thank you.